In this lesson, we are going to calculate the volume of three-dimensional figures. The volume of a figure tells you how much space the figure takes up, or, differently seen, how much space is inside this figure. For all prisms as well as the cylinder, we can use the same basic formula. This formula is the area of the base figure multiplied by the height of the cylinder or prism. If you want to convert this to fit every single figure, for the cube, this will be side cubed. The rectangular prism will have the formula length times breadth times height. The triangular prism, it will be a half multiplied by the base and the perpendicular height of the triangle multiplied by the height of the prism. And for the cylinder, it will be pi r squared multiplied by the height of the cylinder. If we now move on to a pyramid and a cone, we once again have a basic formula that we can use for all right pyramids as well as the cone, and that is simply a third multiplied by the area of the base multiplied by the height. For the square pyramid, this can then be rewritten as a third side squared times height. For our triangular pyramid, that will be a third times a half, which will become 1/6 of the base multiplied by the perpendicular height of the triangle at the bottom multiplied by the height of the pyramid. And for our cone, it is a third multiplied by pi r squared multiplied by the height of the cone. Our last figure is the sphere, and for the volume of a sphere, once again, you need to know this formula by heart. As examples, I'm going to use the same two questions we did in lesson 1, determining the surface area, and now we are going to determine the volume. In example 1, we then again have the building consisting of a rectangular prism and a square pyramid. So, to determine the volume of this building, we have our rectangular prism, which will be length times breadth times height. And to this we add our square pyramid, and the formula for that volume is a third multiplied by the base, which in this case is a square, so that's side squared, multiplied by the height of the pyramid. So the length, breadth and height of this prism is then a 12 by 12 by 16 prism, and then we add to this a third multiplied by the area of the square, which is a 12 by 12 square, and multiply that by the height of the pyramid, which is 8. So the volume of this building is then 2688, and the unit for volume is always the unit cubed. When we now move to example 2 and we want to determine the volume of the figure, we again need to add the volume of two different figures. If we start with the hemisphere, the volume for a sphere is 4/3 pi r cubed, which of course for the hemisphere we now need to multiply by a half. So you could also write 4/6 pi r cubed. And to this we add the volume of the cone, and the cone is a third pi r squared multiplied by the height of the cone. So here, simplified, we have 2/3 pi multiplied by the radius of 11 cubed plus a third pi, once again multiplied by the radius squared, multiplied by the height of this cone, which in lesson 1 we already determined to be 15. So the volume of this figure is then 4688,3 centimeters cubed. Because the volume is about what is inside the figure, it is not influenced by whether the figure is open or closed. That means whether the figure is open or not, we can simply use the formulas as they are, or halve them for half a figure.